construction is dealing with is going to be the point of concurrency called the incenter, which is the point of concurrency for your angle bisectors. So we're going to start by pivoting on the first vertex, which I'll come back and label A here in just a minute. I'm going to swing an arc into the interior. Now, if I call these the vertices A, B, and C, just for reference, I'm going to call this X and Y. So your next part of your angle bisector construction is you're going to come to X, and you're going to swing an arc into the interior of the triangle, and then you're going to come pivot on Y, keeping your compass setting the same, and you're going to swing into the interior again. Now, if you connect from A to that point of intersection, you'll have drawn your angle bisector. Okay, now our next one is we're going to come pivot on B and do that same construction. So I'm going to pivot on B, and I'm going to swing an arc that intersects AB and BC. So I'm going to swing that arc. Now I need to come pivot on those two new points of intersection where I've made the green arc into the interior of the triangle. Okay. Now, between this next step and the one after it, you need to not change your compass setting. So I pivoted on one end point of the arc. Now I'm going to pivot on the other end point of that arc and swing an arc into the interior. Now, if I connect that point of intersection from B to where those two arcs met, I've bisected angle B. Okay, now I need to bisect angle C. So I'm going to come pivot on C, swing an arc that intersects line segment BC and AC. So I'm going to pivot on C, and swing an arc that intersects those two line segments. And I'm going to come to the first point of intersection of that arc, and I'm going to swing into the interior of the triangle. Then I'm going to come to my second point of intersection, swing into the interior. I'm going to connect where those two arcs met. From C to where those two arcs met. And I have a point of concurrency. Now, this point of concurrency is a little different than the one for perpendicular bisectors. First of all, this one is always going to be inside. I did the construction on an obtuse triangle. It's going to be inside if it's obtuse or if it's acute. Now, the next thing we need to do to show you what this construction did is I'm going to take my ruler and I'm going to do a cheat using my ruler and use my ruler to show a right angle. So what I'm actually going to do is take my ruler and I'm going to adjust it so I'm along my point of concurrency and I'm going to be perpendicular to the side opposite. Let's see if it'll let me do this. Won't let me turn it. All right, so we'll go this way. All right, so I'm going to go along here and I'm going to line my ruler up so the edge of my ruler is even with the side of my triangle. I'm almost there. And I'm going to draw that little perpendicular segment that goes from my point of concurrency to my side. Okay, so I've drawn that point of concurrency from the point of concurrency perpendicular to the side. Now I'm going to take my compass and I'm going to pivot on my point of concurrency, and I'm going to extend it the length of that perpendicular segment. Okay. Okay, so it's about the length of that perpendicular segment. I'll change this to black. So I'm going to swing that circle around, and what I find, I'm slightly pivoted off. What I should find, if I do my point of concurrency right, is my point of concurrency will be the center of the circle. Let's get that a little bit better. It's the center of the inscribed circle. Obviously, this one's a hard one to do. Okay, so what happens is it brushes by each of the sides and it's equidistant to each side. Okay, so my construction is very slightly off. My point of concurrency is going to touch there, it's going to touch there, and it's going to touch there. So it's equidistant from each side. It's the center of the inscribed circle. Equidistant, let's see, equidistant to each side.